Lesson 9.6, the dot product of two vectors, Part 1. The dot product is an important vector operation in multivariable calculus. And you're using multivariable calculus because we're having equations in multiple variables. So when we're talking about vectors, we're talking about variables in the x and y direction. So when adding vectors, we get another vector. However, there's two ways to multiply vectors. When we use a dot product, when we multiply the two vectors, we get a scalar. So this is a scalar product, and it's also a directional multiplication. So the dot product is related to the angle between the two vectors u and v. So you end up with a scalar. So if a vector is growth in a direction, then the operations we can perform are adding, multiplying by a constant or a scalar, and the dot product. And that'll give us the result gives us the original vector plus, it's much stronger now because we've multiplied it. Okay, so the dot product of u dot v of two vectors u, which its component form is a1, b1, and v, whose component form is a2, b2, is a scalar defined by this relationship. So you multiply a1 times a2, and then you add to it b1 times b2. So running through some of the properties that we have with dot products, we have to define it because it's a new operation with a new type of mathematics, vectors. So here is our zero operation. Here's how zero works. If you multiply a dot product of a vector times a zero vector, you get zero. If you can change the order in which you add them, and of course this is the associative property, you can use the commutative property with a scalar. So this is the commutative property with a scalar. And then I'm having trouble spelling today. And then we also have the commutative property with vectors. And then we have the distributive property. And then that's just how we're defining. If you multiply two vectors to get the vector times itself, this is this, but when you multiply something times itself, you get the magnitude squared. Okay, so doing a couple of examples here. Given that u is 3, 4, v is -1, 5, and w is 4, -3, we're first asked to find u dot v. So u dot v is equal to a1 times a2, so that's going to be 3 times -1, plus b1, which is 4, times b2, which is 5. So we get -3 plus 20. So u dot v is equal to 17. Okay, so for letter B now, we have u dot v again, but now we're multiplying it times w. Since we already have the answer to u dot v, we're just going to bring that over. So u dot v times w is going to equal 17 times 4, -3. So now we just have a scalar multiplication. So we get 68, -51. Okay, I'm going to leave the other two for you guys to try, so give those a try. Pause the video, and then I'll pop the answers up here for you. There's the answers to parts C and D. If you didn't get those or you're not sure where I got the answers, please ask in class tomorrow. Now let's look at the relationship between the dot product and the angle between the non-zero vectors u and v. So we're going to have to limit our values of theta between 0 and pi. And the reason for that is if we go past 180 degrees or pi radians, you're going to repeat the same values. You're just in the negative direction, or on the negative side of the x-axis. So you're going to end up with the same values. So we have 4 different possibilities here. So the first one is if u and v are in the same direction, then you're finding the cosine of 0. So cosine of theta is going to equal 1, so the angle is going to be 0. Next, if u and v, if that dot product is greater than 0, so a positive number, it means that the cosine is going to be somewhere larger than 0 but less than 1. So you're in the first quadrant. Next, if the angle between the two is 90 degrees, that's when the dot product is 0. And this in vectors is known as being orthogonal. It just means has a right angle. The 2 vectors are at right angles. And we're going to talk more about that later in the lesson. So if you say 2 vectors are orthogonal, then you're saying their dot product is 0. And you know the angle between them is pi over 2 radians, or 90 degrees. If the product of u dot v is less than 0, then we're looking at an obtuse angle. So that means the cosine is somewhere in the second quadrant. The angle is somewhere in the second quadrant. The cosine is somewhere between -1 and 0. And finally, if they're in opposite directions, the cosine will be -1, and that means that the angle is at pi. And as I was saying, as clumsily above, if we just go back around, we're going to end up with the same relationships we did. We'll just be going in the opposite direction. So if we go past pi radians, we're going to be working back this way. And then when we get to the negative y-axis, or 3 pi over 2, we're going to be orthogonal again. And then in the fourth quadrant, we'll be, again, an acute angle. So we're just repeating values. So these are the only situations that we need. So to find that angle between the 2 vectors, we can use this relationship. If theta is the if theta is the angle between 2 non-zero vectors u and v, then cosine of theta is u dot v over the magnitude of u times the magnitude of v. And also, if the angle between the 2 vectors is known, you can show that u dot v is equal to magnitude of u times the magnitude of v times the cosine of theta. This is another way to write the law of cosines. And that's where it comes from. So that's where we're getting the angle between 2 vectors. So let's do a couple of examples here. Example 2 says, given the vectors below, find the angle theta between the 2 vectors. So we're just going to use this relationship right here. We're just going to use, this relationship right here. Okay, for this. Now, you can figure out your dot product separately, your magnitude separately, and then put them in the fraction, or you can do it all in one step, whatever you want to do. And in case you didn't notice yet, these are going to be calculator problems, because if you're finding the inverse cosine, you're going to need a calculator. Okay, so cosine of theta is going to equal u dot v over the magnitude of u times the magnitude of v. So that means we're going to do -12 plus 20 over the square root of 9 plus 25 times the square root of 32. Okay, so theta is going to be the inverse cosine of this. So we are going to have 8 over the square root of 34 times the square root of 32. And you can leave it this way, you can simplify it. You're putting in your calculator, so it's not going to matter. So in degrees, we get 75.964, or if the question asks for radians, it's 1.326 radians. So same for part B. We have W and C, and we want to find the angle between the two of them. So we're going to start with the cosine of theta is going to equal W dot Z over the magnitude of W times the magnitude of Z. So theta is going to be, let me fill in some numbers here first. So cosine of theta is going to equal, if we do the first one, we get 5 times the square root of 2 plus 2 times the square root of 2 over, then we get 25 plus 2, so that's 27. And then we get 2 plus 4, so that's 6. The square root is 6. So theta is going to be the inverse of that. I'll just simplify the top because it's pretty simple. So we have the square root. I'm just going to multiply those together. I can do that in my head real quick. So we get 38.942 degrees, or 0.680 radians. I'm going to stop here. There's two concepts left in this section, but they are a little different than what we were doing. So I think I'm going to stop here and make 2 short videos for this lesson instead of one long one.